So on the top of your packet, the first thing you might want to write underneath these is the operations they're going to make use of. So anytime you have the arithmetic is going to use addition and subtraction. And then your geometric sequences are going to use multiplication. And then you can kind of think of it as division, but it's always going to be multiplication by a fraction. So 2 different operations with these, and then you're going to have 4 main formulas to write out. All right, so to begin here, 2 different types of sequences. Sequence is just going to be a set of numbers written in any given order. And we're going to begin with a ball that is dropped from a height of 16 feet. And each time that it bounces, it reaches a height that is half of its previous height. So you're going to be multiplying by a half. So I listed a little chart here. So after your first bounce, you are at a height of 8 feet. And then 8 times a half gets me down to 4, and then so on and so forth. So this is what we refer to as a finite sequence. And a finite sequence just means that your sequence ends or terminates. The sequence is infinite, it just means it goes on forever. So that would be a sequence that ends with like dot, dot, dot. Most of the sequences that you're going to see are going to have a pattern to them. So once you establish a pattern, you're able to just use the pattern and you don't have to keep writing the formula out any longer. So here's your first formula. You have 16 times 0.5 raised to the n, and you want to find the first term of the sequence. So that's that notation. So this stands for your first term, second term, and third term. So to find your first term of your sequence, all you do is take the 1 and replace it where the n is. So I would just go 16 times 0.5 raised to the first. You guys can all do that in your heads. So half of 16 is just 8. And that is the first term of your sequence. That is pronounced A and then sub 1, or subscript. Next term would be 16 times 0.5 raised to the second. Calculator would be fine. That's just equal to 4. And then I would do 1 more. So the third term of the sequence is going to be 16 times 0.5 raised to the third. Use your calculator, and that one's just going to be equal to 2. So below what you're doing is you're going to take these and you're going to write out the first 5 terms of your sequence. So I like to do these with little spaces so that you've got room for everything. So I need to find the first term and the second term and the third term. And again, those are subscripts. So just be careful with notation. You don't want to show those as exponents. So a sub 4 and a sub 5. When you are given a formula, you're going to take those values and just substitute them in. So if I want to find the first term, that becomes the n right here. So this one becomes your n. So my first term is just 20 minus 1, which is just equal to 8. And again, with these, once you've established a pattern, you can certainly use it, but you got to go at least 3 terms to make sure your pattern holds. So the next one, I'm going to go 20 minus the term I'm looking to find, which is term number 2. So this would be 18. Do it once more, and then I think you can kind of see what's going on here. So you've got 20 minus 3, and that would be equal to 17. So obviously my last 2 terms are going to be 16 and 15. This is what we call an arithmetic sequence, and your common difference is you're subtracting 1 from these. Now you take your next one, and again, build it until you see a pattern, and then just go on your pattern. So I want to find a sub 1. I want to find a sub 2, 3, 4, and 5. So 3, and I want 4 and 5. And you're going to substitute these in. So I'm going to take the 1 and I'm going to plug it in every single place I see an n. So this becomes 1 divided by 1 plus 1. So this is just 1/2. Now you do it again. So the n is the term you're looking to find. So this one's the second term. So I'm going to go 2 divided by and then 2 plus 1. So this would be 2/3. And next, you're going to plug in 3 divided by 3 plus 1, which is 3/4. And if any of you see a pattern, go ahead and use it. Just speed it up a little bit. So my numerator is going to become 4, denominator is 5. Numerator becomes 5, and denominator is 6. So you're just building these. So letter C, I'm going to take these and square them. So I'm going to find once more a sub 1, 2, 3, 4, 5. 1, 2, 3, and then 4 and 5. And you're going to sub in. So it's up to you how much work you want to show on this, because this one's pretty quick. So this would just be 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. What do we think? So far, so good? Your next sequence, you're going to multiply by 3 and then subtract 1 from these. So I'm going to go a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. And then you're going to plug it in. So I'm going to start and I'm going to go 3 times 1 minus 1, which is 3 minus 1, which is 2. Now you go to the next one and you're going to plug in 2 instead. You have 3 times 2 minus 1. So 6 minus 1 is going to be 5. Even if you think you see a pattern, take it at least one more term. So now I'm going to go 3 times 5 and then minus 1. So I would have here 15 minus 1, so I have 14. And then again, just keep going here. So I would have 3 times, oh, I'm sorry, why did I do a 5 there? I'm sorry. Change that. Fix that in a second too. So this one is 3 times 3. There we go, minus 1. So 9 minus 1 is going to change this to 8. And then now I would plug in the 4. So 3 times 4 minus 1. So 12 minus 1 equal to 11. And then I hope you would see the pattern by now. Add 3 to this, so 4. Okay. So that's how you use your formula to find specific terms in a sequence. So another formula here that allows you to find any term of the sequence except the first. So you always have to be given this one, is what we call a recursive definition. Here's how you write a recursive definition. This is always going to have 2 parts. It is not on the formula sheet. There are many different options that you can use to do this. Sometimes that's what makes it difficult. You always have to begin by stating the first term. So I'm going to say a sub 1 equals something. And then you have to represent the pattern that occurred. So what I would say algebraically is the next term of my sequence is equal to something either multiplied or added or subtracted to the term before it. So I'm going to go up and we're going to get that information. So from your bounce example above, what was a sub 1? I think it's in your chart somewhere. A sub 1 is equal to 8. And what was happening here? What were we multiplying these by? 1/2 exactly. So that's what we're going to use. So we're going to just fill in that a sub 1 is 1/2. I'm sorry, a sub 1 is 8. And the value I'm multiplying by is x. So the 1/2, you can just place it right in the front if you'd like, or you can attach it at the back. So there's your formula. It means start at 8, multiply by 1/2. Now it says find a sub 2 using your recursive definition. So I would say a sub 2 is equal to the term that came before it, a sub 1, multiplied by that 1/2. So a sub 2 is equal to 1/2 times the term that came before it, which was 8. So the second term of your sequence is, you go up and check it, should be equal to 4. You guys remember using those formulas in the past? These came from the original question. Yep, it just said use the first number we started with, which was right there. Yep, right in blue. Good question. All right, so flip it over. We're gonna skip that one. All right, so end of the year exam asks a lot of these, and typically what they like you to work with most are these recursive formulas. These tend to be intimidating to look at. So what I want you to do is draw arrows to each part. So it says find the first 4 terms of your sequence. So when we are done here, we're going to want a sub 1, again, subscript. You're going to want a sub 2. You're going to want a sub 3 and a sub 4. You already know that a sub 1 is -3. So if you take the sequence and you pull it apart, what this means in words is that the next term of my sequence. So I want you to physically draw arrows to these, please, because this tends to be the hardest part. So this means the next term a sub n minus 1 stands for the previous term. This stands for the previous term. And then minus n, and n is the term number you are looking to find. So here's how I do this the easiest way possible. So I want to find the next term, which is the second term. So what I do is I look at the term before it, which is -3, and I subtract n. This right here is n. So I'm going to go minus and then 2. So this is equal to -5. Now we do it again. So to find the third term, I look at the term that came before it, which is -5. And then minus n, which in this case is 3. Again, this is the simplest way you could possibly do these without showing which one worked. So I'm going to have -8 with this. Now I do it one more time. So I'll pull the term before it. I'm looking at this one now. And I subtract the 4. So -12. You good with that setup? Again, you can see a lot more complicated ways to do those, but if you just remember what everything stands for, I think that's a little bit easier. So here's another one like that. You want to find the 6th term of a sequence where your third term is given to you as a 12. So 12 is the third term, and you want to take this all the way to the 6th. The third, 4th, 5th, and 6th. And what you're looking to do is either add, subtract, or multiply something. So I'm going to fill in what I know. I know the third term is 12. And what is the formula telling me to do? So the formula is telling me to do 4 times the previous term. So this stands for 4 times previous term. And that's it. So I look at my 4th term, I'm going to look at the one that came before it. And I'm going to just multiply it by 4. Equal to 48. Do it again. Look at the term that came before it. And multiply by 4. Okay, you're going to need a calculator. I think this one's going to get pretty big. So 48 times 4. I got 192. And once more, look at the term before it and multiply it by 4. That's all the work you're really required to show on these. That is 768. How are we feeling with those two so far, okay? Again, those are the ones that always get overcomplicated just because students struggle to plug in, but if you keep it that simple, you'll be in good shape. So next we are looking for the 7th term for a sequence that has this recursive rule. So the next term of my sequence is equal to 2 times the previous minus 3. So please translate this underneath it. It helps a ton. And then minus 3. That's what your formula says. So I'm going to write this out. So I have a sub 1 is 20. And unfortunately, when you have a recursive formula, which is what this gives you, you can't jump right to the 7th term. You have to find everything else that precedes it. 5, 6, and 7. Okay. So formula, I'm going to do what I wrote out on the side here. So I do 2 times the previous. So I'm going to look right at the 20. So I do 2 times 20 and then minus 3. So 40 minus 3 is 37. Do it again. 2 times the previous minus 3. And again, these are going to get large. So 2 times 37 minus 3, everyone gets 71. Do it again. 2 times 71 minus 3. So 2 times 71 minus 3 would be 139. Couple more times. So 2 times 139 minus 3. And obviously, because you're building on your own work, you want to make sure that you're going slow. If you make a mistake in the beginning, it's going to impact these answers. So do it again. 2 times 275 minus 3. So 2 times 275 minus 3, I got 547. And lastly, 2 times 547 minus 3. Final answer, 1,091. You guys feel comfortable doing that? Again, unfortunately, there's no shortcut with these. If you have a recursive formula that gives you the first term and the pattern, you have to build everything else. So getting to what's on your formula sheet, finally. If you look at your formula sheet on the right-hand side, there's a formula that is marked arithmetic sequence. And that is this formula right here. You do not have to memorize it. You will always be given this formula to use. We call it an explicit formula for an arithmetic sequence. And this is used to find a particular term. So this is used to find a specific term. Often it's faster than your recursive because you'll be given more information. Used to find a specific term. Okay? So the sequence you are given is 1, 3, 5, and 7. So very easy. A sub 1 is going to be 1. And the common difference, this in your formula is the letter D. And that is the value in this instance that you are adding, a positive 2. So we're going to use that formula and you're going to solve for the 15th term of your sequence. So I want the 15th term. So over here, I go A sub 15 subscript is equal to. I take A sub 1 and I replace it with 1 plus N is always the term that you're looking to find, which is 15, and then minus 1 and then times the common difference, which was 2. And then really all you have to do is type it in. So a sub 15 is equal to 1 plus 14 times 2. That's 28. So the 15th term is equal to 29. The purpose of this formula is to speed up the process, because often you're not just asked for the 15th term, sometimes you're asked for like the 90th term. So it prevents you from having to write out all of your terms that come before it. Okay, so it's a nice little shortcut. So backside, we're going to quickly find the common difference and use our explicit formula to solve. So number 6, you don't need a ton of space whatsoever. The common difference. How do I get from 100 to 97 to 94? What are we doing here? Yep, minus 3. Find the 20th term. So I'm going to pull the a sub 1 is equal to 100. I am looking for the 20th term. And we know d is equal to -3. So I'm just going to write the formula that's right off your formula sheet. So we go a sub n is equal to a sub 1 plus n minus 1 times d. So the 20th term is equal to the first term plus 20 minus 1 multiplied by -3. And again, if you want, you can just type the whole thing in the calculator like that. So 100 plus, and then this is going to be 19 times -3. And the 20th term would be equal to 43. Again, it's a faster method to find a specific term. So same thing here. What is the 10th term? So I have to establish what my pattern is and where it begins. So those are the 2 things that I need. So a sub 1 is equal to -1. My common difference here is plus 4. And I want to find the 10th term. So I go a sub 1 is equal to, a sub n is equal to a sub 1 plus n minus 1 times d. So the 10th term of the sequence is equal to -1 plus 10 minus 1 times 4. So this is your formula anytime you have that arithmetic sequence. So this is 9 times 4. Answer should be 35. Right. And then lastly for today, we're going to look at your geometric sequence explicit formula. This is also on your formula sheets. If you look right hand side fourth formula down, you're going to see this. So a sub n is still the term you're looking to find. A sub 1 is still your first term. So that's not going to change. But you will notice there is no longer the letter D, and it got replaced with an R. And this is instead referred to as your common ratio. And this is the value that you're going to multiply by. And if it's something that involves division, you just write it as a fraction instead. So the sequence you're given above is geometric, common ratio, sorry, cross that off. From one term to the previous term is what you're looking to solve for. So I know here that a sub 1 is equal to 4. And what's our ratio? What are we doing here? Multiplying by 3? Yep. And then all you're going to do is plug that information below to find the 10th term of your sequence. So down below, I'm going to go a sub n is equal to a sub 1. And then again, make sure you're paying attention to notation. You have subscripts and exponents with this one. So the 10th term of my sequence is equal to the first term, which was 4. The common ratio is 3. And then I go 10 minus 1 is my exponent. when you see geometric sequences, these follow exponential behavior. So a lot of your answers are going to be quite large. So don't think you answered your question incorrectly if you get something really, really big. All right, so here's hypothesis. So you have 4 times 3 raised to the 9th power, and that is final answer 78,732. Again, expect those to be large. If it's a decimal, make sure you hit math and fraction. We change it back to a fraction too. All right, your last example here. Which of the following geometric sequences has a common ratio of -3? So which one are we multiplying by -3? So this, our signs are not changing, so that's out. This looks like we're just subtracting 3. This looks like times -1/3. Looks like right here. Good choice. If you wanted to show something, you could do like 3 times -3 gives me that last term -9. How do we feel with those two formulas so far? So again, we are right off your formula sheet. Arithmetic means abstract. Geometric is just do the multiplication. What I want you to start right now, just so you've got a good 10-minute head start, is you've got these problems to complete. These are just like the first example we did from your notes, where you're just going to sub in, and then you're going to do your recursive examples. Is there a backside to this too? Yes. Backside too, but I gave you a ton of space just in case you want to do your work underneath them. And those of you that didn't complete your Delta math assignment from before break, make sure you do that too. Do a good job on those, because I'll count that as a nice like big quiz grade. If you need anything reset that you want to fix, let me know. I'm happy to do that as well. Okay, so you've got these problems to work on. Formula sheets, feel free to have those in front of you as well.